Good morning, everyone. Okay, so we are back with the third lecture on vectors. Okay, if you remember, we had first discussed in our lecture one. In our lecture one, I had discussed about addition of two vectors. Addition of two vectors. And here what I did was I just added a plus b, or maybe a plus 2b, and then I also did something like a minus b or a minus 2b, okay, or a minus nb, or maybe 2a plus b, whatever it is. So we can do these kinds of addition, which means that here, when I say about addition, it also means that I'm going to add two vectors or I'm going to subtract two vectors. Let me just recall this once again, which means that, and whenever we do this, I have assumed that both the vectors are either parallel or anti-parallel. That's what I have done. I've taken one vector, vector A here. I have another taken another vector B here. Okay, let us say this is 3 units, this is 5 units. And when I say vector A plus B, what I have done is I have just did, since both the vectors are the same direction, I have just added 3 plus 5 and I have given the answer 8 units. And when I say vector A and this vector B once again, but this time when I say this is vector 2B, 2B means I'm going to multiply this by 2 or I'm going to add one more length b over here. Then this should be a plus 2b will be written as 3 plus. Now what will this value be? This will be 3 and this will be 10 units. This will be 10 and thus this will be 13 units, right? Okay, so this is what we can do by adding two vectors which are in the same direction. But now if I want a minus b, okay, two vectors which are in a minus b, then what I need to do is I will draw vector a like this. And when I say minus b, this vector b is in this direction and minus vector b should be in this direction. So this would be my minus vector b, which means this would be 3 units. This would be minus 5 units. Adding up together, so what we can do is a minus b would become 3 minus 5, which is equal to minus 2 units. That's what we got here. In other words, this vector will be symbolically written like this, okay, which is in the opposite direction. And similarly, this vector would have been written as one full length like this, right? This should have been the new length of the vector. What is this now? This is your a plus 2b over here. And this length would have been a plus b over here. This is what we had seen. Okay. Now what we'll do is, let us do one more, a minus 2b. What is a minus 2b? This is your a, which is 3 units. 2b minus 2b. Minus 2b would be minus 10 units. So therefore, this is your minus 2b, minus 2b. So adding up these two, what is your answer? A minus 2b should be equal to 3 minus 10, which should be equal to minus 7 units. Lastly, we had seen about, let us take up one example. This we have not discussed, 2a plus b. What do you mean by 2a? See, I have a vector a here, which means I should now draw a vector 3 units plus 3 units, which amounts to 6 units, plus b. What is b? B is this value, which is b is this value. So I'll write down a is 6 units, b is 5 units. So together, 2a plus b will now be equal to 2a plus b will be equal to 6 plus 5, which is equal to 11 units. Okay, that's what we have learned in our first lecture. Is we have learned how to add two vectors, okay, or how to subtract two vectors when they are either in the same direction or they are in the opposite directions. Okay, this is our lecture 1. Lecture 2, what did we learn? In our second lecture, we have learned something about resolution of a vector. Resolution of a vector. I'm just recalling all those what we have learned so far. Resolution of a vector. Now, resolution of a vector, what do you mean by that? A vector is always denoted by a magnitude and as well as a direction. When I say about a direction, there are two standard directions which we know. One is my x-axis, the other is my y-axis. These are the two standard directions which we know. So if you have a vector either in this direction or in the upward direction, you can always say the vector is along the reference direction, namely x-axis. But what if a vector is neither along x direction nor along y direction, but it is inclined, making an angle theta with respect to the x-axis? Then how do we write it? Now, for this, what we did was we splitted this vector. We splitted this vector OA into two parts. On what basis? We said that this vector's contribution comes from both x and y axis. And as a result of it, this vector is being written in terms of x and y axis, right? So what did I do? I just considered that the vector along x axis is OB, which could be written as OB is equal to OA cos theta, right? So how did I get this? So what I did was I just dropped a line over here and I took up this triangle and then I looked at this OB. This OB divided by OA. What is OB? Adjacent side. See, this is a right angle triangle. In the right angle triangle, OB is the adjacent side, OA is the hypotenuse. OB by OA is equal to cos theta, or OB is equal to OA cos theta. This is what we have got. And then similarly, if I want to have this side over here, that is the contribution due to the y-axis over here, then what do? I take up this triangle once again, and then I want AB here. See, this length is equivalent to AB, right? So I will write AB divided by OA, opposite side by hypotenuse, is equal to sine theta. We already learned about this. So AB should be equal to OA sine theta. Okay, so thus I have now expressed this OA vector. What is OA vector? The actual vector in terms of the OB and OC vector, right? Okay, OC vector, this is also OC vector. Okay, OC vector, that is along the x and y axis. Or in other words, I can say the vector OA is now splitted into two parts, one along the x axis, the other along the y axis. This is what we have done. And yesterday we have also done an experiment, okay, based on this using ophysics.com, which is a website which gives you applets in terms of GeoGebra, and we are just using this. Okay, the entire theme of all these lectures is not to learn things by theoretically, but to do it practically. First, I would like to give an introduction to it, and then we will proceed on to the practical. So based on this, we have addressed something like how do you conduct an experiment, okay, and then we also looked at, okay, what are the variables. Okay, so this was the experiment that we conducted here, and I made a small mistake here, sincerely. Okay, now what we do is, now let us look at this. What did we do? We changed the angle here. What is the angle here? If you look at this is the angle theta, right? So let us go back to this. So this was your x-axis. I don't find time space here. I'll write it out here. This was my x-axis. This was my y-axis, and then this was my actual vector. Okay, and then what did I do? This was my angle theta. I started varying this value of theta. When the value of theta is here, which means the line was here, then I found out what is AX. What is AX? The component of this vector along this direction was seen to be 100. Why 100? Because I took this length of this vector to be 100 units. Okay, and the value of AY was 0, which means this vector was aligned only along the x direction and nothing along the y direction. So that's what we got here. When I increase this value theta for 10 degrees, then I found out, so I dropped a line here. It is like putting a tube light over here. And then what do? The shadow of this line is being felt over here. Okay, so projection that we call. Okay, so therefore, at an angle of 10 degrees, this length was seen to be 98.5 degrees, while this length, the upper length over here, was seen to be 17.4 degrees along the y-axis. Then similarly, for 20 degrees, we got the answers 94 and 34.2. Now, as we keep on increasing the value of theta, you observe that the value of AX kept on reducing. Okay, this is a mistake that I made here. Just rectify this. If theta is increased, AX does not increase. AX keeps on decreasing. This whole thing is incorrect. The whole thing is incorrect. Okay, so therefore, now we see that if theta is increasing, AX is decreasing. Similarly, okay, AY is increasing. This is what we have learned. Okay, make a correction to this in the earlier one. Then, secondly, okay, if you note at an angle, if you find out what is the relationship connecting theta and AX, many of them comment saying that they are inversely proportional. They are not inversely proportional. Okay, remember this. Now, when do we say something is inversely proportional? We say something is inversely proportional only when theta is made as 2 theta, your value of ax should become ax by 2, right? See, when, for example, when I take theta equal to 10 and I double this value, the first value of theta, it is 98.5. When the value of ax was 98.5, when you double the value of theta, it is when theta was made 20 degrees, they should have become hard. Did it become hard? It did not become hard, right? So therefore, this is not inversely proportional. This is what we have learned. Okay. So this is something like designing an experiment, and then you conduct an experiment and you take the readings, and finally you understand what you observe from here. And in this process, you are systematically varying something. What is that you are varying? The value of theta. This variable theta is called as the independent variable. This is called as the independent variable. Why independent? Because you see, the value of theta is varied independently. It is not dependent on anything. You are varying it at your own will, right? That is why you call it as independent variable. This value of ax is called as dependent variable. This is dependent variable. Dependent variable. Why dependent? Because you see, the value of ax depends on the value of theta. And the value of theta is increasing, the value of the ax keeps on decreasing. Can you find out how many dependent variables are there? There are 2 dependent variables here, right? Ax and a. Okay, and 1 independent variable. Remember, in every experiment, let it be physics, let it be sociology, political science, whatever experiment you do, the moment you talk about experiment, there should be 3 kinds of variables. First one is your independent variable, which you can vary at your own will. The second one is your dependent variable, which is nothing but given by ax and ay, which depends upon the value of this one, the value of the independent variable. The last one is known as the control variable. Control variable, which means that this control variable is seen to be held constant. Okay, we are not going to change this. Can you guess what is your control variable here? The value of the control variable is the length of the vector, right? Throughout our experiment, we did not change the length of the vector, which was seen to be 100 units. Okay, this is your control variable. Thus, so far we have learned about how to conduct an experiment and using O physics, and we also learned how to resolve a vector. What are the consequences of resolving a vector, right? The consequence is that the x component decreases, y component increases with the value of theta increasing across the x direction, right? And we also seen that the ax plus ay, see, this ax plus ay is not equal to a. What is a? A is 10 units. See, here it could be equal, but here you see 98.5 plus 17.4 is not equal to 100. There's one more observation. Now, why is this observed? Because you see, this is my ax, this is my ay, and the only relationship connecting them is ax square plus ay square is equal to a square. What is this relationship? Pythagoras theorem. Why Pythagoras theorem? Because you see, this is represented using a right angle triangle. Okay, so we have just recalled whatever we have learned so far. Now what we'll do is, we will continue with this with one more, which is addition of a vector. Right, we are going to add 2 vectors once again. But this time, my vectors will not be along this direction, or it won't be along this direction. But instead, the vector would be in this direction, right? The vector would be this direction. Now, towards it. Now, let us consider an arbitrary vector. This is my arbitrary vector. What is arbitrary? Arbitrary means general vector. Okay, let us consider a general vector, okay, which is not aligned along your x-axis or y-axis, but some other line only. So let me call this vector OA. Now what I do is, now if I say OA, where is the vector? What is the position of this vector? If I ask this question, then you will say, see, the vector is aligned like this. Now, is it along north direction? Is it along east direction? Of course, we do not know. So the best way is that, okay, because we don't have a mariner's compass with us, right? The best way is that put a an x-axis, put a y-axis, draw x and y-axis, and then ask the question, how is this angle inclined with respect to OX or OY? Okay, so let us say this angle is inclined at an angle theta. Okay, now what is our question here? The question is addition of two vectors. Addition of two vectors. And then what we have done is we have looked at the resolution part. I'm just giving a recap of what we have learned. Now, what kind of vectors are we going to add? We are going to add two vectors which are not parallel nor they are anti-parallel. So one vector is like this. The other vector is like this. They're not perpendicular. Okay, there are some random directions. Now, how do we do it? There is one important law. There are actually 2-3 laws which governs the addition of two vectors. But I will teach you only one law here. This law is known as law of triangle addition. This is what we call it as. Now, how do we use it? Let me take this as a vector A. This is my vector B. This is called as the tip of the vector. This is called as the head of the vector. This is once again the tip. This once again the head. Now, what I will do is, when I want to add two vectors, I'll take one vector like this, which is A. The tip is here. Let me write T and this is H. Then I will align the tip of the second vector, okay, to the head of the first vector. See, I am pulling this and I'm aligning it like this also. Okay, this is general rule for adding two vectors, just like your hands together, right? So T with H and H and T are aligned, and this once again you put this H over here. Now you see, now we have joined two vectors. Okay, we have joined from the tip, head to the tip, and then you get this one. Next, what we do is the tip of the first vector is added to the head of the second vector. Now we add it like this. Now you see, this will be your resultant vector. Okay, just a moment. Okay. So now, so we have seen law of triangle addition, which says that if we have two vectors, vector A and vector B, which are at different directions, you can add these two vectors by this method. Okay, let me take up one more example. Now what we do is, let us take one vector like this, and I'm asking you to add two vectors. You see, these two vectors are in 2 dimensions, similar to the earlier ones. Now, how do you add? The first thing is identify what are the tip and head of the vectors. See, the two tips. This is your tip, this is your tip, this is your head, this is your tip, head, right? These two tips and these two heads are, the two tips are aligning together. They should not be the case. So what should I do? I should separate them. What should I do to separate them? I should pull one of these vectors. I will pull this vectors. I'll retain this vector B as such. I'll pull this vector A and align this tip with this head, right? I'll align it with this head. So now what has happened? This T, this is H, this is T, this is H once again. Now what we will do? Now we have joined two vectors correctly. And after that, what we do? We take the tip of one vector, the head of the other vector, and join them, right? So therefore, this will become your resultant vector. Somebody in the classroom asked me, sir, you say that, okay, tips should not be joined. Okay, but you are joining here. See, the two tips, the resultant vector tips and the resultant vector head along with another vector is joining over here, right? That should happen. Okay, so therefore, this is how you have to draw two vectors and then you have to add them. Okay, now I had one more question in my class. The question was that why you are so biased about vector A, why not vector B? Do I get the same answer when I do this? Which means that instead of pulling this vector like this, I'll retain this vector A as such. Okay, and then I'll pull this vector B upwards. I'm going to pull this vector B upwards. Okay, I'll pull it like this. So what is the aim here? The tip should coincide with the H. Right? I'm pulling it like this only. See, once again, this is my head, this is my tip, this is my tip, this is my head. Now, once again, you get a vector like this over here. See, don't you see the direction? So this direction and this direction are parallel, right? So therefore, our process is correct. Am I right? Okay, now I have one more question. Okay, so we have seen vector addition by this method. We have seen vector addition by this method. Let us add the vector in another way also. If I was a student in a class, I would have asked this question. Thank God nobody asked me this. Now, why are you pulling this vector like this? Why can't you pull it like this? Right? So what I will do is I'll keep the vector A like this. Vector A like this. And instead of pulling the vector upwards, I'll pull the vector like this. So you don't want the tips to be joining, right? I will do it in different way. So what I will do is I'll pull this vector like this. I'll pull this vector like this. See, this head I'm coinciding with here. I'm pulling it here, right? I'm pulling it backwards over here. So therefore, this head, this is a tail. This is the head. This is the tail of the second vector. Now, once again, what happens is B plus A. See, you get a vector like this. See, the direction of this vector, direction of this vector, everything is one and the same. Wow, wonderful, right? We are able to get that also, right? So therefore, you can pull the vector in either way, but still it should work. Is there one more way which we can do? Yes, we have one more way. Now what I will do is I will consider, instead of pulling the vector like this A, okay, we have pushed this vector backwards, right? We'll push this vector A also downwards like this, right? So we'll have a vector B like this. This is my tail, this is my head. Earlier, this was my vector, okay, the upward vector. Now I'm pulling this vector downwards, which means I'm pulling it downwards like this. Are you getting me? I hope, right? So this is my tail, this is my head, this is my tail. Once again, you see, so we are getting a resultant vector like this. Look at this resultant, look at this resultant, look at this resultant, look at this resultant. All of them are in the same direction, which means you can add vectors in either of these methods. The only condition that you require here is the tail and head of two vectors should only be attached, right? It should not have two tails and two heads attached. Okay, then the resultant is drawn by completing the triangle. See, if you look at this here, these are the two sides of a triangle. The third side is unfinished. Okay, we are not going to finish directly here, but instead I'm going to pull it in such a way that the tail and head coincide of the two vectors, and later on I'm going to join this. Now, how am I going to join the third line? The third line, I'm just going to put a resultant line over here and then see to it that the head of the resultant vector matches with the head of the, or joins with the head of the one of the vectors, and tail of the resultant vector joins with the tail of the other vector. Simple, right? So we are able to do this, right? So I hope you would have learned something about the vector addition. Okay, when the vectors are not in the same direction, are not in the opposite direction, but in a different direction. Okay, now let us do one more example. Now I have one vector like this. I have another vector. Which direction shall I put? This direction. Okay, maybe I'll not even put this direction. I put this direction. This will be a bit twisting, right? So this is my vector A, this is my vector B. Now, how do I add two vectors? Once again, what do you need to do? You need to identify which is my tail, which is my head. This is my tail, this is my head. This is my tail, this is my head. First thing, okay? First thing we have done. Then what we need to do? Take the tail, retain one of these vectors. Whichever you want to retain, you can retain. Okay, let us retain B, for example. Let me retain B, which means I'm going to retain B like this. I'm going to write B like this. Then take the tail of this vector, join with the head of this vector, which means what? We're going to pull it like this. Now, when I pull it like this, now I am going to get a vector like this over here. Correct? I am going to pull it like this so that this tail coincides with the head. This is my head, this is my tail. So when I say I am pulling, I should see to it that the direction of this vector should not change. I should not pull it like this over here, right? So this is head, this is tail, and this is head once again, and this is tail once again. Now we have got tail and head. See, these are nothing but the two sides of a triangle. Then you need to draw a line like this. This will become the resultant vector, so that the tail of the resultant vector coincides with one of the vectors. The head of the resultant vector coincides with the other vector. Done? Good. So now I hope you are able to add two vectors. Now you have to answer me, how do you subtract two vectors? Okay, I have one vector with the same example I will take, or maybe I'll go to the previous example what we have done here. Okay, and then look at it. Once again, I'll take up a vector A, I'll take up a vector B, and then I want to find out how do I find A minus B. What is your answer here? Vector A minus B is the first thing that you need to do is take this vector. See, this is not in the correct way now, right? Because tails are joining, heads are joining, not joining. So something like this. So I want vector A minus B. First, you take vector A. First, you take vector A. Then this is plus vector B, but I want vector minus B, because what I will now do is I'll write this as A plus of minus B. Okay, so I'm going to add two vectors. Only thing is this vector will be a negative vector. If this is a negative vector, what should I do? This B, I have to pull it in the backward direction. There's no chance, right? I have to do it like this. So this will be your minus B vector. Did you realize that this B and this B are different? This vector is plus B. This is your minus B vector. Next. Now follow the old rules. What are the old rules? The old rule is that, okay, the tails are once again joining here. I don't want them to join. I want to split them. So what should I do? I'll pull this vector minus B upwards. So I'm going to write vector A as such. Pull this vector B minus B outwards, minus B upwards. So this is what I get. What's the last step? Then I'm going to add these two. Now, how do I add? These are the two sides of a triangle. What is the third side? Third side is nothing but take the tail, take the head here. The tails of the resultant vector should join with the heads of the resultant vector. See, resultant vector and one of the vector, resultant vector and the other vector. The heads are joining here, tails are joining here. So thus you see, this is your resultant vector. Got it? Okay. So we are now able to get the value of A minus B also. Now, so remember, vectors are extremely important. If you don't learn vectors now, you will not be able to solve problems later. Now, let us take up one more example. Let us say I want to do this example. Which example is this? I want to take up this. I have one vector here, vector A. I have another vector here, which is B. And I want to find B minus 2A. Okay, totally different. Let us do this. B. So what should I do? Take the positive vector as such. See, I took A here, constant, right? Take the positive vector as such. Okay, don't change it. Positive vector, I'm going to take it like this. Like this. Then minus 2A. What is minus 2A? If A is like this, minus A would be like this. Right? Let me choose a different pen to show you the difference between minus 2A and plus A. Okay, blue color I will choose. This should be your A. This should be your A, minus A. This should be your minus A. If it is minus 2A, I should write like this. This should be your minus 2A. Am I right? So what I'm going to do is, I'm going to draw a vector which is like this. This is your minus 2A. Now what should I do? See, I should identify what is my tail, what is my head. Then similarly, this is my tail, this is my head. Next, what we should do? I should take this tail, join it with the head, which means pull this backwards like this. This is my tail, this is my head, and I'm going to pull it like this. Pull it like this. Right? I have done it now. Now what is this you have got? This is your B vector, this is your minus 2A vector. And now, what's the last step? So we have aligned, we have joined, right? The T with H, sorry, H with T, and then this is your H over here. The last step is draw the resultant. Where is the resultant? Resultant is here, right? So we have got the resultant here, right? This is your resultant vector. Don't think always that resultant vector should always be the largest vector. Need not be. Resultant vector can also be a small vector. Okay. Sometimes your resultant vector can also be 0. When can it be 0? Let us look at that also. Slide, I will write it here. Let us say vector A is like this. Vector B is also like this. Okay. Vector A, vector B is like this. And I am asking you to find out vector A minus B. So what should you do? Vector A you take like this. Vector minus B you take like this. Then you are going to add these two vectors. When I do that, what will happen? You get a 0, right? So how do I get 0? How do you draw it vectorially? So vector A like this, vector B once again like this, vector B once again like this. So therefore, the starting point and the ending point are same, right? So therefore, the starting point, so this point and this point, where is this point? Sorry, this point and this point are one and the same, which means this keeps on reducing, and thus your resultant becomes 0, right? So we have learned much about the theoretical aspects of the vectors. Now what we'll do is, let us go to the practical part. Just wait, let me reshare my screen to get about the vector part. Right, now let me choose a new tab. Now this is ophysics.com. I hope I have shared it. Yes, I think so. Yes, I have shared it. This is URL is ophysics.com. So click on this. This is not my website, nor am I advertising them. Okay, I'm just showcasing how this website could be used, okay, by people to learn physics in a very interactive manner. Okay, I had been suggesting this. Somebody asked me in my previous lecture also, okay, are you in any business? Okay, nobody pays for me this. So I'm just, what we'll do is, let us click on here and go to vector addition and subtraction practice. Let us click on vector addition and subtraction, right? Okay, let us wait. My internet is not that much speed, but take some time, but let us wait for some time. Right, so we have got a Geogebra simulation here. Now what do we do here? We have to add two vectors. Simple. So where is vector A? Vector A slider is here, theta is here. Vector B slider is here, theta is here. Now I need to give some vector values. Let the length of vector A be equal to 50 centimeters or 50 units. Let me give it as 50 units. Okay. And then let the length of vector B, how much will we take? Shall we take it as 50 units once again? Yes, we will take it as 50 units once again. 50 units once again, right? And initially, let me make both of them to be 0. Both of them to be 0. Now what do you get here? Vector A and vector B, both are aligned in the same direction. So A plus B should give you 100 units, and that's what you are getting here. Now if I subtract, what should I get? A minus B. It should be 50 minus 50. If I click on this checkbox, what is the answer you should get? 0. Let us look at this. This is 50. This is 50. The resultant will be 0. There is no resultant. Then you should ask me, where is the resultant here? See, resultant is here. The black color arrow is showing you the resultant. See here, there is no black color arrow at all. Gone. Okay. Now what I will do is, I'll change the angle. Now how do I change the angle? I should keep one of them fixed. The other one I should vary. Okay. So therefore, I'm going to change this angle. Let me make this angle to be 10 degrees. What do you observe? I got vector A aligned at an angle of 10 degree, vector B, which is at the same one. And you see vector A plus B is in midway in between these two. Okay. Now let me make it as 20. Now you see the vector 20 now it gives you, okay, once again, this is a black vector is going in between, and this is a 10 degree once again. Let me make it 30. See, now you observe there's an angle 15 given here. What is this angle 15? 15 is nothing but the angle made by the resultant vector with respect to B. Okay, so if this is 30, this is going in midway, it is bisecting the angle. Okay, let me make it 40 once again. Now if I make 40, what is that you should expect? You should expect that this value of angle should be 20 degrees. Okay, to see whether it works or not. Wow, it works, right? It's 20 degrees. Okay, so which means when two vectors are equal, the resultant vector makes an angle of 20 degrees only. That's what you have assumed. That's what you have got over here. Now, is this the same when you get subtraction. Now, before we start, so how will subtraction be? What is subtraction? It should be A minus B, right? So A would be as such, B would be in the opposite direction. The resultant should be in this direction, right? Let us click on subtraction here. Now you see this is vector A. This blue color vector is vector B. The black color is your resultant vector, which is vectors, the resultant vector over here. And you see the angle here, this is 110 degree. Why 110 degree? Okay, let us investigate that also. Let me go to addition. Initially, when it was A plus B, it was 20. Okay. When it is subtraction, this would be 90 plus 20, which is 120. So it gets added up by a factor of 20 degrees. Remember, these laws are deduced only when the two vectors are equal in magnitude. Okay. If they are unequal, what will happen? That also we need to look at. Okay. Now what we will do is, let us once again choose to be this to be around 0, and I will make this value to be 50. Maybe I'll make it 50 here, and I will make the value of B to be 20. I have made B vector to be smaller, vector A to be larger for some reason. Okay. Now what I'm going to do is I am going to change this angle. Let me make 20. Now what is that you expected? You expected the angle made by the resultant vector should be 10 degrees, right? You have one vector, both the vectors which are aligning, it should be 10 degrees. That's what we had seen there, right? Earlier also. But what is that you get here? You get 13.3 degrees here. Let me make it as 30 once again. What is it you expect now? 15 degrees you should get. Divide by 2, right? But you won't get 15 degrees. See, you get 20 degrees over here. It's a different story here altogether, which means the angle with which the resultant vector makes with the B vector, okay, it will differ depending upon the magnitudes of A and B. Okay, I hope this is clear. If not clear, try to do this experiment once again. Okay, in the next class, next lecture, we will see about, okay, how do you calculate this angle appropriately. Okay, for now, let me stop here. It's almost time, and then we will continue in the next class with the same example once again. Okay, so now, thank you friends for watching this. So